Hello everyone. So now we're going to continue our last video for the networking OSI model. So as you remember, I was talking about IP addresses and subnetworks. And one thing I noticed is I wasn't sharing my whole desktop, so I wasn't able to. I wasn't really showing, my terminal. So as you can notice, if you do IP config in your Windows terminal, so this is what I mentioned. My Ethernet was not connected. So as you can see, my Wi-Fi is connected. You can see it as an IP address and it has a mask. So that's one more thing I wanted to clarify. Also, as you can see, the mask is in a different format. So what does this mean, right? So you can, have your network mask notified in a different format, right? You don't need to have it with the slash with the IP address. So if you just want to specify the mask for this case, right, where you want to all 32 bits, then you set all the bits in your mask. So what you're saying is I want, this is my whole subnetwork, right, with the subnet mask. Similarly, if you're going to do slash 24 minus the last 8 bits, so it's going to be 0, right? And then similarly for 18, we remove the byte again. So it's going to be 0 and 0, right? Mhm. So similarly for 8, I just do 255,000, and of course your mask for this case is going to be all zeros because that means all devices as your mask is pretty much set to 0. So now that's your network mask. And one more thing, like I wanted to show you is, so if you see ipconfig dash all, you can see more information about your interfaces. So this is where I wanted to go over some stuff which we went over in the first video. So as you can see, we have the IPv4 address, so we have our mask, and then we have our lease, DHCP lease information. So here we obtained our lease on Jan 7th at this time, and then there's of course the lease expiry. So that's when your lease, your IP address is going to expire and has to get a new lease from your router. And the default gateway, so like I mentioned for the route, so here it is set to your router. So basically, again, that's my router, and that's my router IP address. So of course, my router has a DHCP server, as I mentioned in the first video. So that's my router IP saying, okay, there's a DHCP server there, and that's where I receive my IP address from. So, and of course, the DNS servers, right? So if you remember in the first video, I mentioned about the DNS servers. Actually, like every device will have the DNS servers configured, pretty much. So in this case, like my primary, you can actually have multiple DNS servers. So there's usually a primary and a secondary DNS server. So of course here my primary DNS server is set to be my router so that it can resolve local hosts with that DNS. But let's say if it's not available, the DNS server is down, my router is given the secondary as the ISP's DNS server, right? So I can contact that DNS server if anything. And I think like if there's no, let's say if this DNS server has no forwarders configured, right, might not have forwarders, so your request will go directly to your ISP's DNS server. Then there's no need for forwarders here. So that might be a little. It'll vary from your ISP and the the company. It varies from company to company how they pretty much decide to configure your internet, right? So that's more information about your interface. So what's the next most important thing is this physical address. So what is this physical address, right? So if you notice, it's similar to the IP address, but you have 2 more bytes. So pretty much this is they refer to as the MAC address. So usually every interface has a MAC address also, like how it has an IP address. So the MAC address is usually, but it's represented in a different format. Usually they don't show the decimal value; they show the hexadecimal value. So to make a distinction. So in this case, let's go back to this. So usually this is the IP address, right? So now if you go to MAC address, so how does the MAC address look? So usually it's like hexadecimal, so I can have 0A, something like that, 01. These are all hexadecimal values, right? 04, so up to 1, 2, 3, 4, 5, 6, so 6 bytes. So that's your MAC address. So what's difference in MAC address in IP address, right? So that's where I was talking about these layers. So the MAC address applies in this layer. So this is another layer of addressing, as I was mentioned, underneath the IP addressing layer, right? So to picture why we need this, first we need to like understand. So let's say for in a use case where you have an application running with a socket, two applications actually, let's say running in the same machine, communicating via a socket, let's say a TCP socket, right? So you're gonna create a socket in the application layer, and you're gonna bind it usually to the local host IP. So if you're aware that your local host IP is usually 192.0.1, so your IP address is set to your local host. So what happens is when you create the socket and send the packet, of course, it goes through all these layers, the transport layer, TCP, UDP. There's some, packet windows and connection protocol involved there for TCP anyway. So that I'll go more detail on these layers on a follow-up video. But for now, so basically when you come to this network layer, it knows that this address is itself, right? It doesn't need to go down to layer 2. So what happens is the packet just goes back into the machine to reach the application, on the same machine. But now let's say it has to go out, right? Let's say you have the same socket running an application in a different machine, right? Connected through Ethernet. Then the packet has to leave all these layers, and it has to leave the network layer and has to enter the data link layer, and then find the machine there, right? So like what I mentioned, if you remember, when you have the subnet configured, let's say you're trying to connect or send a ping, like I mentioned, it finds the subnet and sends the packet. But the thing is, usually the PC does not just send your packet, guessing there's a device with that IP address there, right? So because it's going through this interface and this data link layer, first of all, this address needs to be translated, this one at least. So you're going to ping him. So you can't really leave through the Ethernet with that address. It's not going to find it. So what you need is the MAC address, right? You're going to need the MAC address of this Ethernet interface. So when it goes into this interface, it can find that machine, right? So usually when the IP address comes, it has to resolve. It does not travel. Basically, the network layer does not apply in interfaces, right? So it's basically addressed using the hardware addresses. So in this case, so yeah, so that's your MAC address, right? So what's the main difference between your IP address? So it's not like region specific or anything. It's set by your manufacturer, and usually like your manufacturer is supposed to like have different MAC address values, and I'll explain why that now. For example, so let's say you have two devices, right, in your local network with the same MAC address. So remember how I mentioned you have a DHCP server that gives you the IP address. Usually the DHCP server gives the IP address based on the device's MAC address. So it actually sends a ARP request. This is where I'll get to the address resolution protocol. So it'll send a request to get the hardware addresses of the PCs, and based on that, it'll set an IP address. So, so if you have the same MAC address in your local network, this is going to be a problem. It's going to give you a networking problem because it's pretty much like a duplicate device in your network, right? It's going to receive the packets and it's going to probably send it back. So the thing is, though, this is only an issue if you have two devices with the same MAC address, and the likelihood of that is very, very low because manufacturers, they have their own set of MAC addresses and they recycle it. So when they let's say Samsung, they'll use this range to this range MAC address, and let's say when their device is recycled, they'll reuse the MAC address. So the possibility for a conflict happening at your home, for instance, right, localized in their localized network, because like I mentioned, the network outside is kind of it's like quarantined, so it does not matter. MAC addresses does not matter, and usually it's only working in this network layer, and then it resolves the individual machines in the data link layer. So there it just resolves on its individual local networks, right? So as long as the local networks do not have a machine with the same MAC address, it's not an issue. And like the IP address, it's not like region, it's not split by region and stuff like that. So that's your MAC address. So like I mentioned, now we're going to the address resolution protocols, right? So how does this work? So when you're sending this packet, it's gonna actually ask. It's not gonna send with this IP thing, right? It's gonna actually need. It's gonna send it, but it's gonna be in the packet, but it's not really used in this Ethernet. It's used outside when it comes outside, right? So what we need, what's used in this Ethernet is that Ethernet header. Basically, okay, I'll go into the packet headers in more detail, but in the header you will have. The MAC address, right? So in the MAC address, let's say, okay, so now when you're sending this packet to Ethernet, right? So now you're gonna what's gonna happen is you identify this is the subnet. So what you're gonna do is you're gonna send a request, ARP request. So this is the address resolution protocol, right? So and this is dynamic ARP actually. So let me put this. So in your PC you have dynamic ARP enabled. So that's basically just an ARP utility that's listening to requests, right? So now when you're sending this packet, you're gonna send an ARP request to um, this in your Ethernet, right? It's gonna reach here, and this dynamic ARP is gonna reply saying, "Oh, I have 172.168.2.101 as this MAC address, for instance. Let's put a MAC address next to it, right? So now my Ethernet, I'm gonna answer back to that machine, right? So the ARP is actually broadcasted. So let's say it's connected to a switch or other. The Ethernet is branched out. It's going to send to every device connected. So the ARP is going to answer saying, okay, in this machine I have this interface, right? This is my MAC address. So send me the packet with that address. So now your packet is actually sent not just with this address, which is not used in this layer, right? Because it's the hardware data link layer. It's used when it comes out, which I'll get to in later. So you, like I mentioned, so you have a second address. So you get that address, and basically you add the address in your Ethernet header and send it to your Ethernet. So now your Ethernet will send it to that device. It'll actually reach here and it'll process that packet, right? Because it'll know, okay, this is my MAC address. This is my packet meant for me, and it'll come out of this interface. And when it comes out of this interface is when it comes into the network layer, right? So when it comes into this network layer is when you'll have the IP address, right? So that's layer 2 in MAC addressing. So like I mentioned, there's a layer of addressing below IP addressing. And one more important thing I wanted to go over this layer 2 is virtualization. So it's very important. Okay, so I'll go over some mainly. So okay, let's say in this use case, right? So what's happening when you, okay, let's say you configured your PC, two PCs like this, where one PC is trying to get internet from a second PC through Wi-Fi, right? So there is an issue here. Thing is a performance issue pretty much. So what happens is you're gonna request the machine address, right? And you're gonna transfer it to the machine. And the thing is the packet has to come out in the network layer, right? And then go back out to go into Wi-Fi, right? It's going to have to find the MAC address of the Wi-Fi interface. It's going to do another ARP resolution, and it's going to have to go back through data link. We don't need to do that. We can make it more efficient, right? We can reduce the time and all the delays and everything involved with that. What we can do is make a virtual interface, which is called like a bridge interface, and then we link these two interfaces to that bridge, right, as slaves. So what happens when this happens now, these two interfaces disappear from this layer. So your OS and your operating system in your machine, you no longer have Wi-Fi and Ethernet. They don't have IP addresses pretty much. They'll show up, but they won't have IP. Your IP addresses disappears, right? Because they're no longer in that layer. They're hidden by this single like layer, right? So now what happens is, no, I don't need, shouldn't put a public IP. So now you can put your own, network and mask here. Does not matter because as long as you have the route to make, okay, let's say you want packets to go through the bridge, you just add the route to the bridge. But you can have your own network configured here. Let's say 34 with the subnet, right? So now, as you can see, now a bridge. So what happens is the packets will come in this layer, and the bridge will exist as a virtual interface, and that's what the packets will only enter into network with the IP address of the bridge, right? Because it's entering with the bridge. It's resolving with the bridge. So these two interfaces are hidden in that layer. You no longer see it. The packet does not come in that, and it's pretty much when you, okay, let's say you listen in that interface, you wouldn't see layer 3 packets. You only see it in the bridge. And that's very important because when you want to configure like firewalls and stuff, then you'll configure firewalls on the bridge, right? Because depending on the firewall, if you're using a network layer 3 firewall, then you have to configure the bridge, not the Wi-Fi. There's no point because the packets will not be seen by the network layer. You'll have to configure a layer 2 firewall to configure Wi-Fi and Ethernet, for instance. So why do we do this? Because this is more efficient. So then the packets can go to the Ethernet. Since this is bridged in this data link layer itself, the Wi-Fi gets the packets, right, and we don't have to worry. And it comes out. It is available in the network layer also as a single interface, and you can like listen in or do anything, TCP dump or get the data or whatever in this interface because it's going to come into the network layer, but it's going to go directly through Wi-Fi, so it's much faster, right? You can look at it in as a one pathway instead of going out and then resolving back again, right? Which is why because there'll be two Wi-Fi and Ethernet, and then it has to resolve Ethernet through the layer two again, right? So it's more efficient to have a bridge. So another very important use case is like VLANs. So VLANs is usually when you have, let's say, traffic and you want to like classify it, right? You want to have different classes of traffic, right? Oh, before I get to that, so bridge, I just wanted to mention also static ARP. So you have this dynamic ARP utility which I mentioned, which is the one which answers, right? So if you have an IP address on that Ethernet, I shouldn't have removed it. So it'll have a different IP address, right? You can have the same for the interface. So when you have this IP address and you're trying to reach this machine through this Ethernet, because it's in the subnet, or the route, it's gonna go through here. So now what we have is the dynamic ARP is going to answer back saying, okay, that's my MAC address. But let's say because this is a security, sometimes you don't want your machine to answer its MAC addresses to rogue machines asking it, right? Because this ARP utility is open. There's no security involved. So usually they disable the ARP, dynamic ARP in this machine. So or in any machine. So both machines are not a dynamic ARP, and you just configure the ARP. It's called the ARP cache, usually not the table. So you configure the ARP cache directly on this machine too. So in that cache, you're going to say, okay, let's say this interface is having this MAC address, right? You're going to say, okay, that IP address has that MAC address in that machine's ARP cache. So it's not going to send an ARP request to find the machine, right? Because it's going to look up its cache and it's going to be like, oh, you're trying to reach this IP address. I know it's that, that address in the layer two. So I'm going to send to that interface with that address to find it, right? So, like I mentioned, to be clear, you cannot address with IP in this layer, like through the interface of the hardware. You cannot. It does not find through IP address, right? It can only find through MAC addresses. That's why it's very important. You need to resolve into the MAC address when you're going into the hardware layer. Basically, going into another machine through any interface, even Wi-Fi, for example. So that's basically that, and I'll continue with the virtualization, finish it off. So let's say you have now is the second use case is the VLANs, right? Why do we have VLANs? So the thing about VLANs is it's like, okay, let's say you want to classify traffic. Right now when you have one interface, you can have one sub network configured, right? So you can only your traffic is just coming through one subnet, and you cannot distinguish it, right? You cannot prioritize, let's say, bandwidth. Let's say your use case where you have audio visual data and regular data, which is typical in automotive. You want to prioritize the audio visual data, right? There should be no lag and it should be fast. So now, so what we do usually is, the thing is in the hardware. So I'm going to do so in the hardware you usually have a queue in the interface. On every interface there's going to be something called a queue desk, right? Queue disk. So this is a queue in which the packets queue up, right? And you can configure, so let's say a VLAN, right? A VLAN is like a virtual interface. You're gonna similar to the bridge, but you're gonna configure. So it's gonna be an additional interface, but it's on the Ether. It's a virtual interface that's made. So this I can have multiple VLANs, say VLAN one and then VLAN two. And the beauty of this is I can have them in different subnets, right? So I can have them in a totally different subnet, right? So now it can be 182 because remember, it doesn't matter. It comes out of the Ethernet. I'll explain how it resolves to the IP. So 182, let's say one a three whatever 123.102. So this is a VLAN. It can have its own subnet too. So you can have a very different subnet here. So why do we do this? Mainly, one main thing is you can have like different firewall configurations, right? So you can say traffic, mainly like you can segregate the traffic for like applications. Let's say one application is VLAN one is using VLAN one, another application is VLAN two. So for security, you can have VLAN two have more is more is connected to, let's say, it's having open traffic or something. So you can have more firewall, more strict rules for this IP subnet. But then VLAN one, you can have less restrictions, right? That's just for security. Let's say for prioritizing, like I mentioned, so there's a queue in the hardware, right? So you can specify in the VLAN what priority you want to give it. So you can say priority one and priority two. So in the hardware, the driver has code to, based on this, it's going to look up the packet, and basically there's a header. So if I see the Ethernet header, so Ethernet frame. So you usually, yeah. So let me go to that. So when you go through these layers, each layers usually has a header, right? Like data link. This is where, so if you're traveling through Ethernet, that's where when it resolves the MAC, it's gonna add a header, pretty much, which is just a set. It's just like binary data. You see a value of data. So it has the MAC address. You see the source. So this is the Ethernet header. It's gonna add in a wired interface, right? So if when you have the network, you're gonna have the IP network header. So IP header. So if you look up IP header, you're gonna have, that's another prefix in your packet, and that's where it will have your network addressing, right? The layer three addressing. So this is similar to, you can see source IP, destination IP. So each layer is adding a header to your packet, and transport, of course, will have the corresponding TCP UDP header, right? It'll have TCP header. So similarly, so every this is specific for the TCP application, what the information it needs. So each layer adds headers to the packet for it to get resolved, right? For the, because it's going to come in the other machine or whatever in that layer and has to be resolved. So similarly, like yeah. So in that header, like you can basically specify when you send the packet from your socket, right? I mean, I want to use VLAN one, and I want to use priority as one. So when it goes into this Ethernet, it does not matter what right you put your source, when your IP address. Uh, it'll change, right? It'll become the VLAN's IP because you put the VLAN ID, and then what's going to happen is so it's going to look up the priority, like I mentioned, when it comes to the interface in the hardware and the driver level, and it's going to pick the packets based on that priority, right? So let's say you're sending packets from this machine to that machine. So in the queue, let's say you have two VLANs, you're sending through two VLANs. Let's say VLAN one is more prior, then your packets are going to be prioritized for this VLAN. So you're going to receive more packets in this VLAN than the other VLAN if they're broadcasting at the same rate, right? So that's very important for priority. VLAN, it's called PVID, prioritization. So that's basically layer two addressing and I guess virtualization. I think we'll continue in the next video. I'll go over a little more over the other layers to finish up the OSI model. And I think I will go a little more detail on the packet flow in your machine. So basically, this is how your packet really flows. It's more, involved when it transfers through this OSI model. So if you can picture, so as you can see, so there's many. So these are basically callbacks into the OS. So as the packet comes into the hardware, so there's like drivers, and the drivers will communicate with the OS saying, okay, the back, and it's going to actually call back a function, right? So in the OS, it's going to call back a function. So this is like in the OS. So what's happening? So like filters are like firewalls. So as you can see, filter firewall. So you can put configure the firewall like at each point of the packet, right? So basically, when the packet is in this state or whatever, it's in the hardware, it's going to call back this function, right? And it's about to enter. So it's when it enters this routing decision, so it's going to call the OS back. So when it calls back, you can, so let's say if it's a filter callback, this is actually a function callback. It'll actually check for the rules, right? For firewall rules. So you can configure firewall rules, let's say for input from layer two. And then you can see for forwarding, you can configure rules for forwarding. So all the filters are firewall, where you can configure firewall, like gating and stuff. So there's more involved in that packet flow, and I'll go over that with and finish up the OSI in the next video. Thank you for listening, and have a great night.